Chapter 10, you just learned chapter 10, magnetic material. Magnetic dipole moment for an atom. Then, how many magnetic material available? How to define each of them. Curie temperature, describe the temperature effect of the magnetization. Magnetic domains and domain walls, which exist in any magnetic material. pH curve, to describe hard and soft magnetic material, and application, such as magnetic recording. Okay, an atom. What is the cause of the magnetism? A magnetism is caused by current. The current has to be in a loop. So a loop of current causes the magnetic field. So due to the Ampere's law. And in atom, due to the orbiting electron, that's caused the magnetic moment, atomic magnetic moment. While the electron itself also spin up and also spin down, that's called another magnetic moment. This is called spin magnetic moment. So therefore, in an atom, there will be orbital magnetic moment and the spin magnetic moment. Okay, they can be calculated based on the movement of the electron. And the total magnetic moment for atom is given by the current times this area of the current loop. Boromagneton is a unit to describe what a spin of electron can generate how much a spin of electron generates the magnetic moment. It is a constant which is described by beta. And when the magnetic material per se, is under the magnetic field, it has a magnetization. The magnetization is described by the magnetic fields. So also magnetic flux, magnetic field flux, magnetic flux density, which is denoted by B. B is given by B naught times the magnetization of the material. Therefore, the material, in order to measure the magnetization of material, we introduce a term called relative permeability, which is a function of the magnetic susceptibility. So the relative permeability is 1 plus the susceptibility of the magnetic material. The magnetization is solely due to the external magnetic field intensity H times this susceptibility. So according to this susceptibility, we can classify the material in different categories, such as diamagnetic material, which has -1. Okay? Paramagnetic material has smaller value of susceptibility. Ferromagnetic material has positive value but a large value of susceptibility. Antiferromagnetic positive but very small. Why? Because the alignment of the atom magnetic moment is different direction. Ferromagnetic lie between antiferromagnetic material and the ferromagnetic material. So solely based on the susceptibility. So it has temperature, magnetization has a temperature dependence like this. So at a high temperature, the magnetization is dropping. Why is that? It is due to the thermal excitation inside the material try to disorder the magnetic moment. Let's say at the saturation magnetization state, all the moments are aligned. Okay? And you increase temperature, the temperature try to random those alignments. So it decreases the magnetization. At a Curie temperature, which is the maximum temperature, the magnetization exists. So above Curie temperature, there is no magnetization. There is no magnetization, even though you apply high magnetic field, because the temperature affect the magnetization, affect the magnetic dipole moment alignment. So many material has subunit. These subunits are called magnetic domain. So each material has different number of magnetic domain. That's why I explain why iron is not permanent magnet. Okay, this is because many domains try to align in closely so that the minimal energy is favored. Domain has walls. This is called domain walls, and the domain can also move. Can also move in the way that magnetic field applies. Based on this, we notice that there is a hysteresis loop of the magnetization if you apply the different direction of magnetic field. So this is called a BH curve, and it is solely due to the movement of the domain and the change of the direction of the alignment. So there will be a HC, which is called causivity, which is a maximum magnetic field can magnetize the material. And also have the BR, is called resonance, is the field that when the material is magnetized without, then you didn't, then after that you don't apply magnetic field, then material is still magnetized. So that is due to the BR. That's why permanent magnet can sustain the magnetism for long term. Based on the different HC, we classify the material, magnetic material, magnetically into hard magnetic material and soft magnetic material. The difference is HC. Hard magnetic material has high HC. Soft magnetic material has smaller HC. That means the hardest magnetic material is hard to magnetize or demagnetize, while soft material is easy to be demagnetized or magnetized. The significance of these two materials has different applications, such as for the permanent magnet, tends to be hard magnetic material. For the things used in the transformer coils, which people try to magnetize and demagnetize frequently, tend to be a soft magnetic materials. This basically is the content of the chapter 10.